Hello guys, so welcome to MathBoard. So now we'll be looking at the topic of stationary points, where we analyze a graph of y equals fx and we see how tangents and differentiation can be linked. So firstly we'll be drawing a graph, a basic graph. So if we have a graph like that, which goes like that, so this is y-axis and this is x-axis, so we'll assume this is y equals f of x. So now these are turning points. So when a graph comes like this and curves, we call this point a turning point, because now the function first increases and then decreases. Here the function decreases and suddenly increases again. So these two are turning points in the function. So now we call this point a maximum. Now you might wonder why we call it a maximum, so because its y value is somewhere over here, but if you go through here more up, you'll get a high y value. But we refer to this as a local maximum, which means that it is the maximum in that area. So this point is a maximum, max, whereas this point is a minimum, because it's the smallest point you can get in that area. So now these are the features of the function y equals f of x. So now we'll be looking at how differentiation will be linked in this chapter over here. So now dy by dx, you know, f dash x dy by dx, which is the same as f dash x, has a special property in this function. So if we take f dash x at any point on the graph y equals fx, f dash x will be the tangent to that point. So if we take the point here over here, so if we find f dash x and plug the x value over here, we get the gradient of this tangent over here. So if dash x refers to the gradient of the tangent, tangent just touches that point and passes through. It's a straight line. So it's not limited to a specific point. You can get so many tangents in this curve. So one tangent could go like that, or else a tangent could be decreasing like that over here. So millions of tangents you can get at this on this curve. So f dash x will refer to the gradient of that tangent at that point. So that's pretty simple up to now. So now we'll be looking at another special feature under the differentiation. So we found dy by dx over here, and that refers to the gradient of the tangent. Now another special property is that d squared by over dx squared has something to play over here. So if we find d squared y by dx squared and we check the point, so now we might get an equation, and when we plug the value of x of that point, if d squared y by dx squared is greater than 0, then it is going to be a minimum. And if d squared y by dx squared is smaller than 0, then it's a maximum. So now it might be a bit complicated, but I'll explain this through. So now we know that f dash x is the gradient of the tangent at each point. So now at these turning points, these are special points, these two turning points, dy by dx is equal to 0 at this point. Now you might wonder why, but I'll explain. So the tangent at this point is going to go like that. So it's a flat curve with no gradient, which is the gradient is 0. So this explains why dy by dx is equal to 0. At this point as well, the gradient is going to be 0. So dy by dx is equal to 0. Now it's a maximum and a minimum. So another special property we have to learn is that these two, d squared y by dx squared, if it's greater than 0, it's a minimum, and if it's smaller than 0, it's a maximum. So these are special things that you need to keep in mind when analyzing a graph. So it might be a bit complicated to you at first now, so we'll look into a question and get things solved out. So we'll get an question where y is equal to x to the power 4 minus 32x. So that's a question. So we'll look at how we can analyze that. So now first, if we are supposed to find the stationary point, we have to use this theory we just learned. Dy by dx is equal to 0. So if we have to find the stationary points of this function, y equals x to the power 4 minus 32x, we define the dy by dx and equate that to 0. So now we'll find dy by dx, which is equal to x to the power 4. When you differentiate, it's 4x to the power 3, and minus 32x, it's going to be minus 32. Now we use this rule, dy by dx is equal to 0, so 0 equals 4x cubed minus 32. So now if you simplify this, x cubed is going to be 32 divided by 4, which is going to be 8, and x is equal to 2. So that's that. So x is equal to 2. So when x is equal to 2, there is a turning point in this graph, in this respective graph. So now we found the stationary point, and if we want to find the y value also, we plug this into this original function, which is y equals x to the power 4 minus 32x. So y equals 2 to the power 4 minus 32 into 2, which is going to be 16 minus 64, which is going to be minus 48. So the coordinates are going to be 2 comma minus 48. So now we found the coordinates of the stationary point. We'll name it as S. So that's pretty simple, and now we'll be looking at d squared y by dx squared. So if we find the second differentiation, so d squared y by dx squared, that will tell us whether the stationary point over here 2 comma minus 48 is a maximum or a minimum. So now we find d squared y by dx squared, which is going to be, we have to differentiate this over here, so it's going to be 12x squared, and minus 32 vanishes. So when x is equal to 2, so our stationary point is 2 comma minus 48, and we plug x is equal to 2 over here, so it's going to be 12 into 2 to the power 2, which is going to be 4, that's going to be 48. Now we found the d squared y by dx squared. So d squared y by dx squared is 48, which is greater than 0, so it's a minimum. Now we found that the stationary point is 2 comma minus 48, and since d squared y by dx squared is greater than 0, which is 48, it's a minimum. So that's pretty simple, and this logic applies everywhere in this chapter. So it's up to you to find these questions and do more of this practice and excel in this. So thank you, and hope you have a nice day, and hope you learn this pretty well. Thank you.